Welcome to The Explainer. Today, we're going to build a digital thermometer completely from scratch. And trust me, by the end of this, you'll see just how easy and powerful this little project really is. All right, here's the game plan. We're going to start with what we're trying to build, then meet the tools of the trade. We'll uncover what makes this little sensor so special, get our hands dirty with some wiring, and then bring the whole thing to life with a bit of code. And of course, we'll wrap up by looking at what cool stuff you can do next. So, you ready to jump in? Okay, let's get right into it. You know, every great project needs a clear goal, and luckily for us, ours is super straightforward. So what you see here, that's our entire toolkit. The plan is simple. We're going to connect this little temperature sensor to the Arduino board using just a few wires. The goal? To get it spitting out live temperature readings right onto our computer screen. Seriously, that's it. We're turning these simple parts into a real working device. All right, time for some introductions. Let's meet the two key players in this project. We've got the brains of the operation, and then we have its sense of touch. So, first up, we have the Arduino. This thing is basically the brain of our whole operation. It's a tiny little computer that we can program. We're going to give it a set of instructions, and its job will be to chat with the sensor, ask, hey, what's the temperature, and then report that back to our computer. And here's the other half of our duo, the sense of touch. This little guy is the DS18B20 chip. It's the real heart of our sensor module. It's the part that actually feels the temperature. You know, there's a reason this is a huge favorite for hobbyists. It's cheap, it's reliable, and it's surprisingly precise. So, let's talk specs, because this is where it gets really cool. This tiny sensor can measure a massive temperature range. We're talking from a crazy cold, -55, all the way up to a scorching 125 degrees Celsius. And yeah, we're using Celsius here. It's just the science standard. But switching it to Fahrenheit in the code is a piece of cake. The best part? It's accurate to within half a degree. I mean, for something this tiny and affordable, that's just incredible. Okay, so what's the big deal with this sensor? Why this one? Well, it all comes down to a couple of superpowers it has that make our lives way, way easier. First off, it uses this really slick communication system called the one-wire protocol. And it's exactly what it sounds like. The sensor only needs one single wire to send all its data back to the Arduino. I mean, come on, that's awesome. It makes the wiring so much cleaner. And that one-wire protocol has another amazing trick up its sleeve, something called parasite power. This is so clever. It means the sensor can actually draw the little bit of power it needs to run from the data line itself. Yeah, you heard that right. In some cases, you can get away with not even using a separate power wire. How cool is that? All right, superpower number 2, a unique identity. Every single one of these sensors rolls out of the factory with its own 64-bit serial number lasered right into it. It's like a unique fingerprint or a social security number. And why does that matter? It means you can hook up a whole network of these sensors to the exact same wire, and the Arduino can just call out each one by its name. No confusion, no mix-ups. It's a game changer. Okay, enough talk, right? Let's get our hands dirty and actually build this thing. We're going to wire up the circuit, and I promise it's way easier than it looks. You only need 3 little jumper wires for this. Seriously, just follow the diagram here. The signal pin, that's the one marked with an S, that goes to digital pin 4 on your Arduino. The middle pin goes to 5V, that's our power, and the pin with the minus sign goes to ground or GND. Boom. That's it. The hardware part is done. All right, hardware is all hooked up. Now for the fun part, the magic ingredient, the code. It's time to tell our little creation what we want it to do. Okay, before we start coding, we need to give our Arduino a little cheat sheet. We're going to install 2 things called libraries. One is called One Wire and the other Dallas Temperature. Just think of them like language packs. They teach the Arduino how to understand and talk to our specific sensor. And the best part? You can install them with just a few clicks right inside the Arduino software. So, the code. Every Arduino sketch or program has 2 main chunks. This first part is called setup. Just like it sounds, it runs one time and one time only, right when you power it up. Its only job is to get everything prepped and ready to go. You know, start the communication with our computer and tell the sensor to wake up. And then there's this, the loop function. This is the main event. It just runs over and over and over again, forever. And inside this loop, our code is doing 3 super simple things. 1, it asks the sensor for the temperature. 2, it sends that temperature reading to our computer. And 3, it takes a quick 1-second break. Then it just does it all over again. And this is the moment of truth.
You hit that upload button, open up a little window called the serial monitor, and there it is, a live stream of temperature data coming straight from our sensor, updating every single second. How awesome is that? We did it! Project complete.
So look at that. We just built a fully functional digital thermometer. That's a huge accomplishment. But the real question is, what's next? Where can you go from here? Hey, remember that unique ID we were so excited about earlier? Well, this is where it gets really powerful. Because of that feature, you can start adding more sensors, and more and more. You can connect a whole bunch of them to that single data pin and start measuring the temperature in all sorts of different places at the same time. So let's just take a step back and look at what we've accomplished. In just a few minutes, you've learned the absolute fundamentals of an electronics project. You now know what an Arduino does, how a digital sensor works. You've seen the magic of the one-wire protocol, you've wired a circuit, you've uploaded code, and you've read live data from the real world. That's a ton of stuff. So that leaves us with one big question. Now that you can measure temperature pretty much anywhere, what are you going to build? Think about it. You could create a smart thermostat for your room, an automated system for your garden, or maybe a warning system for your computer if it gets too hot. The possibilities are literally endless. So, what's your next project going to be?